Here we are at Unit 4, Lesson 2, Relationships in Triangles. We've already started to look at some of the constructions that are necessary to understand to be able to deal with some of these relationships in these triangles. Today we're going to look at some more of the bisectors of triangles. So to be able to use bisectors of triangles, to be able to find the circumcenter and the incenter. So you've already learned about the perpendicular bisectors and the angle bisectors. Now we're going to apply those to triangles to be able to find these points of concurrency. And then we'll use the points of concurrency in a real life situation as well. So some of the vocabulary is concurrent, point of concurrency, circumcenter, and incenter. So what does it mean to be concurrent? Well, to be concurrent is when there's three or more lines, rays, or segments that happen to intersect. So they're intersecting with each other, and they all intersect at one specific point. We call them concurrent. So you can have concurrent lines, concurrent rays, concurrent segments. So here's an example where you have concurrent lines, because there's arrows on the end. And then once you have concurrent lines, then you have something called a point of concurrency. So what is a point of concurrency for this situation? Well, in this particular situation, the point of concurrency is going to be point P. And any point of concurrency, again, is that point where all of those lines are intersecting each other. Okay? All right. Now we move into circumcenter. Circumcenter is going to be a type of a point of concurrency. Now, in particular, the circumcenter is going to be a point of concurrency of the perpendicular bisectors in a triangle. So if you have a triangle and you find all of the perpendicular bisectors of the sides, right, of all the sides, then you have what's known as the circumcenter. So in this situation here, you'll notice that the circumcenter is at point P. So you have the perpendicular bisectors all meet at point P. In the diagram, the blue lines are your perpendicular bisectors. And then there's a theorem. Of course, there's many theorems in geometry. So in this particular theorem, it says that the point of concurrency here of the perpendicular bisectors, aka circumcenter, is going to be equidistant, or the same distance to each vertex. So from that point P going to each vertex, points B, A, and C, they're all the same distance. So from the vertices to that point of concurrency of the circumcenter, it's the same distance. Now, this is just to give you an idea about some of the words, the terminology. Again, it's called a circumcenter. So circum means around or about. And in this case, we're looking at the circumcenter of different types of triangles. So if we have an acute triangle, then you have the circumcenter is going to be in the center. And again, it's a circle that goes on the outside of that acute triangle. If you have a right triangle, the circumcenter happens to be on the hypotenuse, again, because it's the center of a circle that goes around and it touches each vertex of that right triangle. And then finally, if it's an obtuse triangle, circumcenter will be outside of the triangle itself, because the circumcenter is the center of a circle that goes around the triangle and touches the vertices. So part of a memory aid is circumperpen. So circum meaning like the circumcenter, and then perpen from perpendicular bisectors. Now you can use it if you want, you don't have to, but circumperpen, it's just kind of a funny phrase, but sometimes that gets stuck in your head and you'll remember it. Now here is a real world example that you can go ahead and read through it and try it. So now that you've looked at this particular situation, you're asked to figure out the location of the distributor of the ice cream. So again, each vertex is a distributor. So if we're trying to find a place that's equidistant to those vertices, we're going to look for the circumcenter, because basically you've created a triangle. So if you can find the circumcenter, then you know that those distributors would travel the same distance. So in this case, it would be located at point D. Now again, you could do a construction to do this if you need to on your, you can actually do it on your computer using GeoGebra, or you can do it by hand on your paper. Now, what if you need to figure out the location or the coordinates of the circumcenter if you have a triangle like this? Well, what we can do is we can try to figure out the equations of the lines of where they would meet is going to be the circumcenter. Now, you only need two, actually, of the equations. You don't need all three. If you use two of them and create a system, because we know that we're dealing with the concurrent lines, the third one's going to have to go through that for it to be part of the circumcenter. So let's walk through then how we would go ahead and do this. So first, you can graph the points on the coordinate plane, then you can see where everything is at. Next, you want to try to find the equations of two of the perpendicular bisectors. So we know that the slopes of, you know how to find the slopes of a line that's perpendicular to another line, but you also know how to find the midpoint, right? So we can use those to help us to figure out what the equations are. Once we, in this particular situation, have the midpoint and we have the perpendicular, the equation of the line that's perpendicular, we can then use those as a system to be able to solve. So wherever they intersect is going to be the circumcenter. So in this case, it's going to be 3, 1. You could graph, when you're graphing these, you'll see where their intersection is, and that is an easy way to do it. You can also do it, again, algebraically to figure this out with the system another way.